This video is intended to be a quick review of factoring a greatest common factor, or GCF. So we've got 5 problems here, and factoring out a GCF, again, is just like undistributing. You learned how to distribute terms into parentheses back in algebra, so now you're kind of undoing that. So what you want to do is look for common factors of your numeric part of your terms, your coefficients, or factors of your variable part of your terms, like your x's, your y's, or whatever happens to be in your expression. So looking at number 1, we want to look at both terms and ask ourselves, is there anything I can divide out? So first we'll work with the numeric part, the coefficients. 10 and 5, those are both divisible by 5. So that would be the common factor of the coefficients. Now look at your variables. You've got x to the third, you've got x squared. You can only factor out the least amount of variables or power that you have. So I have a power of 3, I have a power of 2, so the most I can divide out or take out would be a square. So I've gone through the coefficients, I've gone through all the variables. My GCF for that expression would be 5x squared. That's your GCF. So now what we're going to do is factor out that GCF. We'll place it in front of the parentheses, and we write inside what's left after factoring that out. So it's basically division. 10 divided by 5, that would leave me with a 2. Now when we divide exponents, when we divide variables with the same base, we subtract the exponents. So basically you started with 3, you're taking away 2, so you're left just with 1 power of x. Operation was a subtraction symbol, so 5 divided by 5 is 1. You can write a 1 there if it helps. And then you have 2 x's and you're taking away 2. So you've factored out all of your 2's, so all that's left there is a 1. So 10x to the third minus 5x squared, you can factor out a 5x squared from both terms. That leaves you with the quantity 2x minus 1. So that would be it. How can you check to see if you've done it correctly? If you wanted to, you don't have to do this, but you could check to see if you distribute that back in 5x squared times 2x, that would be 10x cubed. 5x squared times a negative 1 would be negative 5x squared. And you can see that matches what we started with, so we factored it correctly. So on the next one here, again, look at your coefficients, look at your variables. What can you factor or divide out? Notice both terms are negative. So that's a common factor. The negative will go as a common factor. You got 4 and 8. You can divide both of those numbers by 4. Now look at your variables. You've got x cubed on the first one. You've got y squared on the second. Since they're not the same variable, I can't factor them out. I don't have x's on both terms. I don't have y's on both terms. So x's and y's aren't common to both terms. So therefore, my only GCF is going to be that negative 4. So when I factor that out, divide it out, negative 4 divided by negative 4 is just a 1. So that leaves you with 1x cubed. Now I'm not going to write the 1 there, but it is there. So you can just write x cubed. Negative 8 divided by negative 4, that would leave you with positive 2. And the y squared, which I didn't take out. Moving on to number 3. Again, see what you can divide off of each term. Negative 12 and 10, both are, they've got different sides, so you're just going to factor out a positive factor here. 12 and 10, the biggest number you can divide to both of those would be 2. Do you have x's on both terms? You do. You've got 2 on the first, 1 on the second, so you can only take 1. You can always take your lowest amount. You've got y's on both terms, and you've got 3 on both, so you can actually take out 3 for both of them. So your GCF is 2x y cubed. After dividing it out, what are you left with? Negative 12 divided by 2 would be negative 6. 2 x's, take 1 away, leaves you with 1. You're taking all your y's away, so move on to the next term. 10 divided by 2 is 5. 1x minus 1x, all the x's are gone. 3 y's, take 3 away, all the y's are gone. So close it up, all done. Last one here, lots of terms, lots of variables. Bigger numbers, let's see if we can get this here. 54, 36, and 90. At first glance, you might think, oh, I can divide all of those by 9, which is true. You can divide every single one by 9. Here's the problem with doing 9 though. If you think about 9, and I'll kind of jump ahead here. If you divided out 9, 54 divided by 9, okay? 54 divided by 9, that would give you 6. 36 divided by 9 would be 4. 90 divided by 9 would be 10. Now look at 6, 4, and 10. You could still divide out a 2 out of all 3 of those numbers. So if you pick a number and you divide it out, and you can still divide out another factor, you did not pick the biggest number that goes into all 3 of them. So actually 54, 36, and 90, biggest number that goes in all of those is actually 18. So make sure you find the biggest number that divides into all of your terms. X's, do I have an X on each term? Yes, I do. I've got 3, 4, and 6, so I can take 3 out of each. Y's, do I have a Y on every term? I do. I've got 5, 2, and 3, so I can take 2. And then there's actually a Z in here. I've got a Z on the first term, but I don't have it on the next 2, so I can't factor out any Z's. So my GCF would be 18x cubed y squared. So what's left over after I divide? 54 divided by 18 would be 3. 3 minus 3 for my x's is none. 5 y's, take 2 away, I have 3 left. And of course the z, which I didn't remove, plus 36 divided by 18 would be 2. 4 x's, take 3 away, leaves me with 1. 2 y's, take 2 away, they're all gone, so minus. 90 divided by 18 is 5. 6 x's, take 3 away, leave me with 3. 3 y's, take 2 away, leave me with 1 y. So that would be my solution. So there is your review of factoring a GCF.